Welcome, everybody, to another episode of the To Carnivore podcast. Today, we're very lucky to be joined by Dr. Gundi Rhoades, who is a veterinarian, but also very much a jack of all trades and has some interesting information about environment, cows killing the planet, some insights into glyphosate, Bovaer, should we be feeding seaweed to cows, etc. It's going to be a really interesting conversation. Dr. Gundi, welcome.
Hello, Simon. Thanks for having me on your podcast.
My absolute pleasure. I'm looking forward to chatting with you and getting to know you more. First of all, as a veterinarian or a vet, as we say in Oz, I'd be curious to hear your perspective on nutrition when it comes to both animals and humans, because I know you've looked into carnivore and you've got an interest in human nutrition as well.
Yes. Well, unlike doctors, veterinarians we learn a broad range of animals and all of the digestive systems that there are, and they're all different. Like a chicken is different from a cow, is different from a pig, different from a horse, different from a dog and a cat. And of all of the animals, actually, Simon, we are probably the closest in our digestive system related to the dog. Some say pigs, but really the whole digestive system of dogs is very similar, sort of like a gut and the length of the small intestine and the large intestine and so forth, So yeah, so I've had a nutrition interest since I was 20 when my mom got sick and she got breast cancer. And she discovered a whole food diet at the time. And I was still at uni, I lived in Germany, I was at uni. And so whole food, Dr. Otto Brucker, like Weston Price, Pottinger, like I have known for 40 years. And so I have always been into whole food. And then that came through the whole career of mine, which is now 35 years long, that I had a look at nutrition. And now, of course, as a veterinarian, I'm in the country, like rural, and I lived and worked on a cattle property as well, breeding Angus cows and first breeding bulls and offspring heifers and steers. And so, like I got introduced to all of this Australiana, Australian cattle property life, which was just awesome. And I did that until about 3, 4 years ago when the drought just killed, my enthusiasm for farming for a while. And I sold the farm then. But so in that time, I was working as a vet. My 3 children were growing up, and I also was breeding cows, like weighing them, castrating them, and so forth. And then when the bull breeding operation stopped, I thought, oh, well, I might as well go organic. And then I started to discover the organic principles, and then I discovered grasses, and then I discovered soil. Meanwhile, shall I just keep talking?
Yeah. I'm enjoying this. Go on.
Meanwhile, like I've built up my clinic, which is now 23 years old, first on the farm and then here in the little town of Inverell, treating all of these different animals, so cows, sheep, goats, horses. I'm a real jack of all trades in my profession. I literally do everything, from artificial insemination in horses to pregnancy testing cows, pulling calves, bull semen testing, bull cow nutrition, internal medicine in dogs and cats and guinea pigs, orthopedics, soft tissue surgery, dermatology, ophthalmology. Like it's a typical vet's life. This is what we do. Yeah. So, and then always following human nutrition and then the human demise that, like we talk about a lot nowadays. Suddenly, my God, people are sick. What is actually happening? In my little town here, 16,000 people or so, like which has got a lot of KFC and McDonald's. And in the 27 years that I've been here, I could just see the decline, and especially in the children. And then, the dots started clicking sooner or later.
I mean, we often find that vets are taught so much about nutrition at university, whereas doctors aren't. I mean, if you apply a vet's eye to human physiology, to our digestion, to how we use and make energy, what do you find, and what do you think we're overlooking?
Oh, we are overlooking that we are ancient beings. That's one. That evolution has done a lot with us and to us. We have co-evolved with nature. I think we forget that. I look at human medicine and I see a pill prescribing disaster, where
Mm.
the principles of the body are not understood anymore. While, we in veterinary medicine, we are really big in, I studied in Germany and it was a good University of Hanover. So I'm really strong on the basics like biochemistry, physiology. How does digestive systems, how does it work? The pancreas, the stomach, the intestine, the Krebs cycle. What is ketosis? Cows get bad ketosis when they're starving, so for us, it's really second nature. And we learn, like we had an institute of animal nutrition at my uni. So we do a lot, so we've got a really good understanding. And I cannot believe that the medical profession does not learn that. We had hours and hours and hours. With us, everything is about food. If you don't feed it properly and cow put on that they get diabetes. They are a meat eater. Why should they get diabetes? Because they're eating 60% carbs. And then you're in the picture what's happening with the human bodies.
Sorry, Dr. Gundi, you cut out there, but you were you talking about animals getting diabetes? I just sort of picked up the end there where we lost a bit of reception.
Yeah, yeah, it's the same as, why does a meat eater or a hyper meat eater like a cat get a carbohydrate related disease? Yeah, and as a veterinarian, that diabetes is carbohydrate related in most cases, like is an old hat. And I can't believe that doctors still don't really seem to understand that, like, and it sounds really arrogant now, like, but you're looking at it from the outside, it appears to me that those basic primary school, university principles are not understood anymore. And that's where vets are just really strong at,
Yeah.
so yeah. So dogs and cats get diabetes because
Wow. Never
also,
heard that before.
yeah, and not as often as in people, but they do. And why? Like, yes, their pancreas might be completely fried, like from some infection or from really severe pancreatitis, which dogs in particular like to get. But also, like, why do we feed our cats and dogs 60% carbohydrates in commercial dog and cat foods, right? They
Mm.
shouldn't. They should have the same as, a carnivore diet in a person, like they're more carnivore possibly than we are, but they are certainly carnivore, like, and so what are we doing with feeding cats 60% starches? And of course, because it is industry and it is money and starches are like grain, like are cheap. And then a lot of people can buy grain-free cat and dog food, and then we have peas in it.
Mm.
Like if you ever had a dog or a cat and you give it like your leftover dinner with some peas in it, they will eat around it. They don't want them,
Mm.
so, but
Yeah. I
in,
mean, it's all in there for one reason, and that's to cut costs. It's got nothing to do with animal nutrition. They're just trying to pad it out with something else that's cheap, got a cheaper input cost than meat, which is really what the animal should be eating. And it's the exact same with humans. You go to a restaurant or you go to a shop or you buy anything packaged and you look at the ingredients, it's all plants because it's cheap
yeah,
to produce that. You can preserve it easily and you hide it all and just pad it out. And people have
yeah.
no idea what they're eating. But that's really interesting that plants get diabetes. Oh, sorry, that animals like pets get diabetes. I never heard that before.
Mm,
And I think the one of the fundamental differences between vets and doctors that I've picked up on is that vets are aware that that pets and horses and cows are animals, they're part of the animal kingdom, and that they thrive in nature. Humans are no different. We are also animals. We're just the apex predators. We're just the smartest ones, and we thrive in nature as well. So, what is a natural diet for us? Well, it's predominantly or exclusively just meat and animal fat. But so many people fail to make that connection. When we were sort of getting started before, you said to me that cows aren't vegetarians. I mean, that will blow a lot of people's minds because cows generally eat nothing but grass and foliage and plants. So how are they not vegetarian?
Yeah, I think that's a really good point, Simon, too. So if I just step back a little, like so I love cows, and there is a book out there which summarizes it quite nice, which is Cows Save the Planet, by Judith Schwartz. She's an American journalist. But however, how do cows function and why are they so important? And should we eat them or not? And do they destroy the planet or don't they? And what happens in their physiology? So let me just describe the physiology first, yeah, and go back into the human gut and the stomach and the dogs and let's put horses in there too, and all the ruminants. So we even got to go back further, right? Photosynthesis. So in the air is CO2 and sunlight, and the plants use that, they breathe that in and they build up glucose in their leaves, in the chlorophyll. And that glucose, and this is really important to understand these natural principles, so the plants will build up biomass out of the thin air. But then, of course, there's other stuff in food as well, like magnesium, selenium, calcium, phosphorus, molybdenum, boron, manganese, and so forth. And that must come out of the soil. So this is a principle that I really always happy to share out there. All your nutrients that you need come from the soil. They must come from the soil, from nowhere else. So the plant builds itself up. And the sugars, it makes either sugars and it pumps them into the ground, to feed the microbes, or it builds up its own biomass as branches and leaves or a flower head or a tomato. And that can either be, as you know, either in the form of a starch or in the form of a cellulose. And cellulose is commonly called fiber. And starches we can digest very easily because we've got the starch, enzyme amylase in our saliva and in our gut. And, you eat a potato, it'll be in your bloodstream in 5 minutes or in 10 minutes. You might as well just eat sugar, and this is pasta, rice, all of the starches that you're eating and that the carnivore diet so beautifully avoids, and all of these starches and sugars and fructoses and whatever you have that are built up by these plants in the first place, are highly, of course, diabetes triggering, obesity, cardiovascular disease, inflammation triggering, they're sitting there. So then you have got cellulose, and starches and cellulose are really very similar. They are just glucose molecules put into one row like pearls on a string. And in cellulose, every second one is switched 180 degrees. So it sounds a bit nerdy, everything. It's biochemistry, yeah? But in starches, all the 6 little carbon is the same. We can split that up very easily. It elevates your sugar in your bloodstream. But if you eat cellulose and every second sugar molecule is switched and faces down, up, down, up, down, up, down, we simply cannot digest that. And neither can a cow. Yeah. Which is so important because we can't digest fiber. So who can digest fiber? A cow can't digest fiber either. Neither can a horse. So how do they get away with it in digestion? How can we have cows all over the place, eating grass and getting fat from that? So it is, and everything in biology is bacteria when you really think about it, So the bacteria in the rumen, which is the big first stomach of the cow, it's full of it. And you put one drop under the microscope and you have got about millions and millions of bacteria, which you can see, in protozoa. And the bacteria have got the capacity to break down cellulose. So in your gut, they're sitting in your colon. Most of them should be,
Right.
right? And so all the fiber that you're eating goes doodle, 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 through your gut into your colon, and that's where your bacteria are sitting. And that's the food that you left over because you actually can't digest it. Yeah.
Mhm.
So in a rumen of a cow, they are in the first stomach. So that's where they are breaking up the cellulose effortlessly all the time. And if you give a cow antibiotics and you kill the bacteria, they will starve to death. And I've seen this lots and lots of times. So they are
Interesting.
100% like dependent on the bacteria in their gut. And by the way, you feed a koala antibiotics, they will die. You feed an oyster antibiotics, they will die. You feed a kangaroo antibiotics, if you feed a horse antibiotics too much, they will all not because they can't digest the food. Any grass, cows, sheep, antelopes, zebras, elephants, like their whole digestive system runs over bacteria and protozoa, which is amazing. So then what happens is that they split up these long chains of sugar molecules all together as fiber into simple sugars. And then they cut them again in half. And those are your volatile fatty acids, butyrate, pyruvate, and the whole metabolism starts there. And then they make those volatile fatty acids, which is half a sugar, into fats, and that goes into the liver and blah, blah, blah. And then you get a fat cow that you can sell or eat, right? Or bacteria that they multiply within 20 minutes. So you do the maths, 1, 2, 4, 8, 16, 32. Within no time, you've got an explosion of bacteria there. And what are bacteria? They're little animals made out of proteins and out of fats, and they've got a cell membrane and a cytoplasm, and it's full of proteins. So that is then, and then it goes into the next stomach and the next stomach, which is like ours, and then the small intestine, which is like ours, and that is what the cow eats.
So the
Yeah,
cow's
and that's
actually eating the bacteria.
the cow is actually eating the bacteria. Yeah. So
Cool.
cows are high protein and high fat eaters, but they have got, I call it a mobile biodigester that they carry around with them. And when you know how big it is, like it's about 1.20 meters long and 80 centimeter wide or something, like half the cow
It's a lot of
is,
grass.
it's a lot of grass. And when you look at them, they eat nearly all day, they ruminate, you know. And now talking about a horse, if you ever have owned a horse, you know that I always say you push the money into their mouth and they pull it out the other end. They are really not good food digesters because they have got their bacteria sitting in the big colon, at the end of their digestive tract. Yeah.
Right. And
And
you
so
can
they are
tell
very
that because if you look at the stools of a horse, it's like grass clippings. Whereas if you look
yeah,
at it of a cow, it's smooth and brown and you can't even
yeah.
see
Yeah.
the
And,
grass.
like talking about, like why are we not cellulose fiber eaters and digesters? Like I do equine dentistry as well. So horses' teeth and cows' teeth and other herbivores, other animals that eat a lot of plants. Horses eat like 23 hours a day, but they grind and grind and grind. And they have got teeth that have got about a good 3, if not 4 inches of a reserve crown in their big head. So they grind the tooth down constantly, the pulp, the nerve, the bit that hurts when you have got a toothache, it's at the top and then it goes down, so bone gets put into the inside of the tooth. And so the pulp recedes, the tooth grows, and they do that until there's nothing left, with the tooth. And that is what we then do, because if they don't grind it off 100% even, then, like they get sharp edges, and they can hurt them. And so this is what we as equine dentists do, like we take these enamel edges off. But so their teeth, elephants, the same, like show us that they are just grinding, 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 grinding. We don't have the grinding surface, but our bacteria are so far down our digestive system, they're sitting in the colon, so, and that is and we don't have like a meter and a half long cecum like a horse does. So we poo it out very quickly. So even if our bacteria do a bit of vitamin B6 production and volatile fatty acids and butyrate and so forth, which we absolutely need, we need them, they still, it doesn't stay in our colon long enough to really be enough for us of having vitamin B6. But if you're a cow and you've got your bacteria in your rumen, and they are vitamin B1 producers, you are getting plenty. Yeah, which is really fascinating. So, can I talk about the soil?
Yes, but I've just got a question for you on that. So I'm sort of comparing the cow eating the grass or plants to humans eating the plants. And the cow's eating it, it's going straight into their rumen or this big sort of chamber that then gets filled up with bacteria, and the bacteria are feeding on all the grass. And then the bacteria make their way through the digestive system of the cow, and the cow's actually eating the bacteria. So in that instance, is the cow also getting glucose from the grass, and are they able to actually use that glucose?
Yeah, 100%. 100%. But I tell you a story, so I had a bull that was a show bull. So he should have been Hereford, that should have been really big and heavy. And, and what happens we can talk about feedlots later, what happens when people want to pump them up and make them really big and butch and fat so that they win a show or they're in a feedlot. Farmers give them a lot of grain. Now, grain is a starch. Within 10 minutes, you have got that
Oh, sure.
as sugar. And then the pH in the rumen just drops really quickly. And I had a whole bunch of cows the other day, here in the local high school, where the kids didn't close the gate and the cows went into the grain. And within like 2 hours, a lot of the cows were dead. Like we lost about six or seven of them. And then like some I could save. And so when the pH drops and it gets really sour really quickly, through the lactic acid that is forming, bacteria most of the bacteria die and one survives, which is lactobacillus. And then that makes everything even more sour, like yogurt sour. And then that rumen attracts the water, they go into shock, and very quickly they absolutely die. Yeah. But in a lot of cattle, in feedlots or in intensive feeding systems, they're sort of running on the edge, of being what we call acidotic. And so they're not dying, but they're not really healthy either. And this is what happened with this big bull. He was fed grain, his beneficial bacteria died, the bad ones for cows took over. And so he lost his ability to digest grass and fiber. So the hay that he was eating all day, but he lost so much energy. When I looked at him, I thought, God, you're starving to death. There was nothing of him, just big head and no body. And then he literally could not get up one day anymore. He had no energy. So then I've got a mixture of bacteria, EM, effective microorganisms, which is like 80 different bacteria, which seems to fit into the rumen quite well. I gave that to him, and within half an hour, he had the energy to get up. And then he recovered, and that is just to show how they do use the glucose, yeah, from the cellulose when they have bacteria that can split it up.
Right.
Yeah. So within half an hour, so he started to eat the grass. Now he had the bacteria that could cut it up because no other life form on earth can cut up the cellulose but bacteria. Isn't that amazing?
Mm.
We can't. We cannot. Even cows cannot. It's only the microbes that can.
Right. So
Okay.
so what happens when what happens
Mm.
in a human example when a human eats plants? I assume they can somehow get the glucose, but then the cellulose or the fiber ends up in our
In the colon.
colon,
In the
and
colon.
then
Yeah.
we don't have
And
enough bacteria in the colon to break it down, and then can we eat the bacteria like a cow?
You eat them less, but like the gut microbiome, which we are now discovering how important it is. It needs, and there's a question for you, like, do the bacteria get enough food from the carnivore diet? I don't know, like,
Mm.
but you might know. But my thinking is you feed your body with meat and fat, so protein and fat. And if you eat starches or not, I try to avoid them. And let's say fruit or any simple sugars that you're eating, yogurt, that feeds your body and it gets digested in the stomach and the small intestine. And then in the large intestine is where your bacteria are sitting, and that is your gut microbiome. And that is hungry and that wants to eat. What can it eat? What did you leave over? You left all the fiber because you can't digest it, because only bacteria can. So now the microbes in your colon will cut up the cellulose that is, and cut it up into sugar molecules because they are hungry. The microbes in the gut of a rumen, or the microbes in the soil, really important, and we must talk about that, like in the soil, they all want sugar. They like that cut up biomaterial. Yeah. So that is their energy. And then what do they do for us? So bacteria in your gut make butyric acid, which heals your gut. They make serotonin. There's your mental health. They are the ones that take tryptophan, and we can talk about where tryptophan comes from. They take tryptophan, tryptophan plus the bacteria, Clostridium sporogensis or whatever, or lactobacillus, different ones have got different jobs, makes tryptophan into 5-HT and serotonin. And then that can go via the gut-brain axis and your bloodstream into your brain and make you happy. And then because we don't have enough tryptophan nowadays anymore, and I can talk about why, doctors as an antidepressant give patients serotonin uptake inhibitors, yeah, to make that little serotonin last longer, because it's our happy hormone, right? So melatonin needs tryptophan plus the bacteria, which are transformed into melatonin, and that makes you sleep. Yeah. So bacteria in our gut are so super important. Yeah. So they make your neurotransmitters, they make GABA, which calms you down, dopamine, even oxytocin, which I learned at uni is only made in the brain, seems to be also made in the gut and by the gut microbiome. So yes, to my mind, like they want to eat something, and the fiber is what we leave over. Does it answer your question?
So you're saying that in a way humans can digest fiber because we have bacteria in our stomach that can break it down.
Yes, and if you don't have, yeah, we don't have them in the stomach.
Right.
Not none in the stomach, none in the small intestine. They're living at the end of your digestive system, just before you poop it out. Yeah.
Okay.
So this
Yeah.
is the colon. So if you have got people that had a colon removed, like for irritable bowel syndrome, for example, they will have real trouble because those neurotransmitters and biologically active substances, there's kynurenine, there is IPA, there's so many. We are only just discovering. Like without a gut microbiome, we are really stuffed. Like when you listen to Natasha Campbell McBride, like who developed the GAPS diet, like when you listen to I just finished the book Change Your Diet, Change Your Mind, Georgia
Georgia
Eat.
Ede. Yeah.
Like diet has got, yeah, everything to do with our mental capacity, like, and our body capacity. So yes, we absolutely need our gut microbiome, and that is fed by fiber because it's undigestible to us before. And when we
Right.
take antibiotics, when we eat preservatives all the time, when we kill our gut microbiome, and when we can talk about glyphosate in a minute, because glyphosate is patented as an antibiotic. Yeah, so you eat bread with glyphosate, the glyphosate will be, killing your gut microbiome with devastating consequences that the glyphosate people do not even think about.
So you mentioned earlier on that the human gut is similar to a dog. So what is an ideal diet for a dog then, as a vet? What do you recommend?
Oh, same as us, pretty much. You can just really nearly extrapolate that. Like lots of meat, animal fats, peculiarly, animal dogs get pancreatitis and acute inflammation of the pancreas very easily when they have
Yeah.
too much fat. I have not worked out why and how we can prevent that, because humans seem to thrive on a high fat, high animal fat diet. Yeah. And with dogs, you got to be a bit careful. And
Yeah,
then, like,
I thought dogs needed to be on a leaner diet.
yes, and I really don't know why, because in the wild they would have eaten anything.
Yeah.
So what happened there? I've not found anybody that can give me an answer. If there's anybody out there that can give me an answer, some natural sort of vets say that if the animal fat is not cooked, if it's raw, but I've had
Mhm.
dogs with pancreatitis as well. But yeah, other than that, very, very similar to us, whatever, like eggs, coconut oil, and the same things are poisonous for them. So when we talk about leaky gut, for example, like leaky gut caused by, I think the main culprits are gluten and glyphosate. The inflammatory conditions that dogs get, arthritis, ear infections, red ears, itchy ears with all the consequences of that, food allergies, itchy skin, cancer, I think that is pretty much diet related. Really hard to, well, an allergy is relatively easy to prove because you can do an elimination diet, and you take them off the offending item and then they get better. And it's interesting listening to a lot of carnivore podcasts, I have all of these cases of people, that get better when they just are on a carnivore diet. And yes, a carnivore, it's got the most complete protein of all, with a complete set of amino acids, with healthy, in my opinion, like healthy saturated fats all through, but also what you're not eating, what you're eliminating
Yeah.
is so important. And what you are eliminating in 9 out of 10 cases, is just gluten and the glyphosate, and they always come together.
Yeah, I think that's a really big part of it. We always say that essentially a carnivore diet gives you all the nutrients you need so you can get up to fully covering all bases as far as nutrients are, and it really reduces the toxic load. And maybe once upon a time we could have handled more plants because we didn't have the same issue with GMO cropping and things like glyphosate. And when you eat a carnivore diet, you're really eliminating all of those things from the equation, and you're just sticking to the most nutritious food. So yeah, I definitely think that is a benefit of carnivore that maybe wouldn't need to exist as much in a world that we weren't spraying chemicals on all of on our crops. So could you talk to me a bit about where glyphosate is used, how it's getting into the food system, how worrying is it?
Yes, absolutely. I got really so worried about the whole environment, in the drought in 2018 and 19, and I don't think anybody in the whole world will forget the wildfires that we had.
Yeah.
So I'm really deeply connected to the whole regenerative agriculture movement. Like I'm on the board of Carbonate, which is a charity about that, and Regenerate Earth, with Walter Jenny. I learned a lot from him about water cycles, and so I'm really yeah, very, very involved because I've got such a concern for Mother Nature. Yeah. And now with the carnivore diet, I think one of the main things that pushes people nowadays into a vegan or vegetarian diet is moral concerns about eating animals,
Yep.
which is valid, and I am such a like I hate cattle in feedlots, and that we talk about that in a minute, why they are so bad. And yet even the environmentalists push cattle more, into the MLA and people like that, Meat and Livestock Australia, or even colleagues of my profession, they say we need to have more cattle in feedlots, and I would really like to counteract that argument. But so vegetarian and vegans so definitely want to save the planet. And then I look at it. I live in northern New South Wales, and if I drive just 10 minutes west of here or an hour and a half, I end up in the wheat belt, in the cotton belt. And when you look at how people are farming, most people are not aware how we are farming. So on my cattle property that I had, like my cows were always outside. They had they had a bull in with them, then they got pregnant, and then they had a calf out in the paddock. And most of the time, they did need no help from me at all. And occasionally would pull a calf and help it. I would use no poison whatsoever. I had eagles and sugar gliders and birds and herons and you
Lovely.
name it. All the animal could live on my or other people's cattle properties pretty much together. Yeah. So in in growing vegetarian food, let's say the pasta or the ingredients for the Impossible Burger, yeah, which is canola oil, wheat, soy, which is so high in estrogen, like if you want to have man boobs, eat soy, eat soy, um, so high in estrogen. Or what else is there? Corn. Yeah. So they are the main crops that are being grown. And when you drive to Maureen, Narrabri, Gunnedah, on this wheat belt here, you will not see an insect. You will not see a bird. You will not see a frog. You won't hardly find snakes. I mean, they're still around somewhere. But the rivers are dead. Um, there's either irrigation systems, and I was just there about 2 weeks ago at a cotton conference, and there was no talk about biology. It's about money. And don't get me wrong, farmers are doing it tough. And even cotton is not making much money, and they are just at the call and beckon of the agronomists. They were trained in universities, and they don't know anything about soil biology. They know about soil chemistry, but not about biology. And when you understand soil, I studied soil for a year, for years, but for 1 year extent intensive with Elaine Ingham in America. And when you understand soil, then you know how bad that is. So those soils buy chemicals like fungicides, glyphosate, 2,4-D, paraquat, dicamba, and whatever else is out there. So this is how wheat growing, cotton growing, sorghum growing, maize, soy works. You have got a probably GMO seed stock for the start that you buy from the agronomist. And then you plow your field, which cuts all the mycorrhizal fungi. There goes all your biomass, all your carbon dioxide, all your water that should be kept in the soil is now puffed into the air, like lies there in fallow, more oxidation of the sunlight. We checked soil, and it can be up to 70 degrees in summer when it's not covered by vegetation. And that's what happens in industrial farming. The chemicals that we put on kill the soil. Plowing kills the soil already, and it's probably beyond this podcast today. But mycorrhizal fungi are the king of the kingdom. They're an amazing part of the ecosystem. Organic matter in the soil, water holding capacity is held onto that, and we have all completely oxidized, dried out, desertified, vast landscapes on planet Earth. Like probably about 40% of the landmass is under agriculture, and we've killed most of that. The Middle East, like huge landscapes, the middle of America, Argentina, Brazil, you name it. And yes, we deforest for cows, not good and not right and shouldn't be. But what industrial farming, growing crops for your daily bread does is far worse, and there's nothing alive. And why I glyphosate, as the commercial name Roundup, but it has got other names now too, is such an evil molecule. I called it an evil molecule. And when I called it evil molecule on LinkedIn, my post was just scratched, right? So there is humongous money behind it. Because when you look at the food industry is the same as agrochemical industry, the same as the petrochemical, and the same as the pharmaceutical industry. So we are talking about the biggest players on planet Earth.
Yeah.
And they're not well-meaning, and they do not have the betterment of mankind or humankind or ecosystems at their heart. They just want to make money for the shareholders or for themselves. And so this is why it is so hard, to get any real progress made in this manner, and why the universities are not teaching soil biology and teach soil chemistry. Yeah. So chemistry, the agronomist will tell you have to buy more urea because you killed your natural cycles of farming. So now you have to buy urea. And suddenly it's 4 times as much money as it was last year, and the farmers are the meat between the sandwich, right? So glyphosate is an antibiotic. It is also a chelator, and it is also an antifungal agent. And it is also a chelator of minerals. And so let's go, and it mimics glycine, which is the smallest amino acid. Are you still with me? Yeah.
Yeah, yeah, I'm still with you.
Yeah. So
Somewhat.
let's go back to soil. And I'll tell you why this is so important. So in living soil, in 1 teaspoon, you have got more bacteria than stars in the sky. Yeah, more than people live on Earth in one little teaspoon. So you healthy soil, which is like chocolate brown humus, it's got aggregates, it sticks together. It's not like sand that just falls apart. It's a living system. And incidentally, it is the biggest carbon storage that we have on planet Earth. It's more carbon, and CO2 is the one of the climate inducers, right? We have released massive amount of carbon dioxide from fossil fuels. This is really old carbon that we add to the atmosphere, heating us up, undoubtedly, yeah. But we've also released all the CO2 from the organic matter in the soil. Yeah, so the soils over there in Moree, where they put glyphosate on, which is an antibiotic, so it kills all your microbes, it kills all the protozoa. You will not find an earthworm in those soils anymore. There are heaps of earthworms in Australia. People had to stop the tractor and get the earthworms off the plow. Yeah. And then after our farming methods, there is not one of them. It's just like sand and it's hard as concrete. When I was there in 2 weeks ago, in the cotton country, and they had like core samples where they drilled into the soil and got it out. And I took them and it was literally like this. Yeah, that was not soil. That was concrete when I took this soil and banged it. Why? Because the organic matter that is rotten stuff, like the bacteria and the protozoa and the earthworms and the little nematodes and whatever else is in there, takes all of these detritus that lands on top of the soil, draws it down into the soil. And if you've got some beautiful cows, they trample it into the soil, and then you've got organic matter. And then if you've got organic matter, that holds an immense amount of water. So the second and even bigger greenhouse gas is water. Yeah. So we have released it from all our agricultural land through growing, as I say, vegetarian food and released it into the atmosphere. So now these poor farmers are absolutely not drought proof. Yet, if they would do natural farming with biology, they nearly would be, because the water doesn't even infiltrate into the soil, it just runs off. Where does it end up? All that runoff, plus the glyphosate, plus the paraquat, plus the 2,4-D, goes down the rivers. Fish kill in the Menindee. We had a huge fish kill now, where the water of the Murray-Darling was going, I think it was the Murray-Darling going out into the sea in Adelaide. Fish kill. Why? Agricultural runoff. Not from cows, but from the impossible burger ingredients, yeah, of sugar,
Yeah.
wheat, and so forth. So glyphosate chelates. So the farmer comes and sprays glyphosate, which is a herbicide. So there's weeds coming up, he's plowed and now the weeds come up and he wants to get rid of them. So he drives over, you can smell it, you can see it, and so kills all the little plants that are growing. So it's a herbicide, it kills. Why does it kill plants? Because it stops a process called shikimate pathway. That's when it gets interesting. What is the shikimate pathway? We don't have it. And that's why the glyphosate people say you can drink it. It doesn't kill us. It's not poisonous for us. Yeah, because we don't have, it's a biochemical pathway in plants, algae, fungi, protozoa, bacteria. What does that shikimate pathway do? It makes absolutely necessary ingredients for life. One of them is folate. If you haven't got enough, then you get sort of spine problems in babies. Yeah, folate is really, every pregnant woman takes folate. Should be have been made in the soil. Yeah. And then when I wrote my book, I went into a little detective work. So okay, shikimate pathway. What else makes it? It makes amino acids. Which amino acids? Amino acids are, as you know, the building blocks of our protein, which then are in your carnivore diet, 100%, right? So there is 8 amino acids that are essential. Essential means we can't make them. So if you're on a vegetarian diet, you're probably deficient in those essential amino acids. The other 12, sometimes it's 9 and 11, like 8 and 12, but the other 12 our bodies can make So it's good to eat them, like, but we don't really need them, like we can make them ourselves. But the eight, when you look where they come from, and yes, they are in meat, but now, so I'm writing my book, and I say, yeah, okay, meat. So tryptophan. Tryptophan is an amino acid that is made by the shikimate pathway, which is killed by glyphosate. Okay, but it's in meat, isn't it? So then I read somewhere, mammals do not make tryptophan. It's an essential amino acid. Even cows can't make it. And so I thought, okay, plants, so you go into whatever, PubMed, Wikipedia, Science, like, and you find, oh, plants might make tryptophan. And tryptophan is so important because tryptophan makes your serotonin, your melatonin, your vitamin B6. Tryptophan is building block of every protein structure in your body. And it is also made into IPA, which is your Alzheimer's protection. It protects you from getting plaques. So tryptophan, probably not even made by plants. So who makes tryptophan? So I went rabbit hole down and I found that only bacteria via the shikimate pathway make tryptophan. So now we are pouring glyphosate on every inch of agricultural land that is not organic. What do? We kill the things that make tryptophan for us. And we wonder why we have got a population that is absolutely anxious, suicidal, and depressed. Yeah, like I don't know. I think
Yeah.
its dots really are together. So what else does it do? Kills bacteria. What else do the bacteria make? And then I found and you can do this at home, like go onto a computer and find out where vitamin B1, B2, B3, B6, B12 is made. And you do the same thing that I did with the tryptophan. You find, oh my God, they are exclusively bacterial fermentation products. Like our gut microbiome makes a bit of B6. Yeah. In a cow, the rumen microbiome makes vitamin B1. You kill the bacteria in the gut of in the rumen, and they will get very quickly B1 deficiency. What does that look like? The brain gets mushy and disintegrates and becomes literally a mushy soup. B1 deficiency. We are all B1 deficient. Why? Yeah. Who makes it? The bacteria. Where are they? And this is why meat is probably so, so, so good for us, especially from ruminants, because they have got these bacteria in their rumen and they're feeding it via, herbaceous mass. But it should also be made in the ground, in the soil, and that is what fertile soil is. So all the B vitamins are from bacterial fermentation products. So you can extrapolate what happens when we kill them with glyphosate. Yeah. And then they should be transported, what the bacteria made by the mycorrhizal fungi, which are like super nutrient highways, and they can be a kilometer over there. And they would find that vitamin B3, let's say, from that bacteria and quickly, via its hyphae, delivers it to the plant. And the plant delivers it into its leaves or into its grass blade, and then the cow eats it, and then you eat the cow. Yeah. So all of these nutrients in cattle, in grasslands where the farmer has not sprayed chemicals, these nutrient cycles are
Still
working.
occurring. Yeah.
Yeah. When you go out to Mori, Canada, Narrabri, and you go into where they've killed it, and then they spray fungicides, because a crop might get a fungus, rust or something, so the fungi, so the mycorrhizal fungi are there. Now the chelating means grabbing, hooking. Yeah. So glyphosate is a chelator. And that's what its origin started after the Second World War, like in the 60s or something. They used it as a brass cleaner for pipes. And then they discovered, oh, look, it kills things around it. That must be a good thing. Maybe we can use that in farming. It killed all the grass around that water tap. What a concept. However, all these
Mm.
factories needed something to do. So they put the glyphosate on, and now it chelates all the pluses. Yeah, so all the cations, magnesium, selenium. What else is there? Magnesium, selenium, calcium, phosphorus, selenium, iodine, all of those that are in the ground. And when you really think about it, yes, you can eat a steak, and it has got all the minerals that you need in it. Where did they come from? Yeah, the cow wasn't born with them. And then, because they're born at 25 kilos and then they're suddenly like 500 kilos. Where do they come from? They must come from the soil. So what happens if and that works in most cattle properties, it works. But if you want to eat like your magnesium, because magnesium is in chlorophyll, it's in green leafy vegetables. But if it is caught in the soil by glyphosate and chelated and not let go, there's where your nutrient deficiencies come from. Now you suddenly have to take magnesium in a tablet, right? Or
Mm.
your calcium. So this is not talked about in modern
Uh,
farming. Why are the things that we grow so nutrient deficient? They might look like a tomato, but they have got nothing in it. Why? And so if I can just go back, all your B vitamins are made in the soil. All your minerals are actually not just chelated by glyphosate, but they're also, how do you get magnesium into a plant from your soil? You have to get it in through the bacteria and the protozoa. So like go back 3 billion years, and we had rocks, and then the first life form was bacteria. So the bacteria have got acid around them and they actually mine. Yeah, they nibble on the rock and they make it soluble and they put it in a biological form so that then your plant can take it in. So if you kill the bacteria by glyphosate and consorts of chemical agriculture, even urea kills, yeah, as a fertilizer. NPK fertilizer kills all the microbiome in the soil. Yeah, so you don't have anything mining it anymore. And then to make it even more interesting, you have a soil food web down there, where everything eats everything. So the bacteria are a bit like a fertilizer bag that's in a shed, not available. Yeah. So they then made the minerals and mined them and have them now in them, but then they have to get eaten by a protozoa. And then the protozoa vomits or poops it out, and then it gets into the plant. But it even gets more interesting now, so sorry, I get a bit carried away when I talk. So interesting. So have you heard about rhizophagy ever? No? So rhizophagy was discovered only about 10 years ago by these two gorgeous scientists at UQ here in Queensland, and two women. And then they got sort of forgotten, but an American, nice guy, James White, professor for agriculture, found it and took it up. So all of them, I say thank you to. So they've got amazing electron microscope pictures. So what actually happens with the bacteria, and this is why I would question when we say the tomato makes, or like the spinach makes that vitamin or that nutrient, because these bacteria are sucked into the peristem, which is like the tip of the root, and then you can see them go up and down like a yo-yo, and they leave their cell wall outside, and just as a protoplasm or as an endophyte, now we call them, they go up and down like a yo-yo and come out on the side through the hair roots. And then that cycle goes again. And when they're inside the plant, then they deliver the nutrients, the B vitamins, the minerals, and so forth. So I think with that concept, that life is microbial. Yeah. So and research will come out, and there will be more and more talk about that. But the first producer of nutrients, and then add the polyphenols and the phytonutrients, so the minerals, the B vitamins, and all the essential amino acids are all bacterial products. And glyphosate is an antibiotic, and we're killing life on Earth. And then you eat glyphosate, and then it's in your gut. And then it kills your microbiome in your gut too. And there's research on PubMed. You can all find it. It's all referenced. Like you can find it that, research, or we give these, individuals glyphosate to eat, and then bang, 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 those bacteria are now dead in your gut microbiome. And the interesting thing is, like I see a lot of dogs with Clostridium, diarrhea. It quite often comes back as Clostridium perfringens. And in people, Clostridium perfringens really makes people sick. Clostridium difficile can even kill you. So the interesting thing is that glyphosate kills most bacteria and fungi, but it doesn't seem to touch Clostridium so much. So why do I find Clostridium perfringens all the time? When I do a PCR panel of dogs' diarrhea, because it's a dysbiosis. Where does the dysbiosis come from, right? And to make glyphosate even worse, you go and Google. I think Zach Bush was the first that actually did this research. It also, just like gluten, it dissolves the tight junctions. And then you are at the real bottom of the problem because
Leaky gut.
now, within 15 minutes, you have got from glyphosate, in the minutest little dosage, you have got leaky gut. And then, as a medical person, you can, all the diseases that we have got nowadays, chronic diseases, most of them, autoimmune diseases, Hashimoto's, arthritis, even depression, um, multiple sclerosis. Yeah. Since we have started using glyphosate in the 1970s, 80s, and really in 1991, we started everywhere. And apparently it doesn't matter.
Oh man.
Apparently it's fine.
Yeah, how devastating. Switching gears to another cheery topic, Bovaer. Is that something we should be concerned about, and what is it?
Yes, you should be concerned about, if you go onto Wikipedia and you Google what it is, not 3-nitro, I've forgotten. Um, and then you look at the P and the H numbers, the potential hazards and the hazards, you have got everything in there. Do not eat, do not breathe in, do not do this, do not do that. So it's very highly toxic and we're feeding it to our cows, yeah. Seaweed is also, like the red seaweed in particular, everybody is going on about, and we reduce methane. And yes, you do. But why do you reduce methane? And now what all of the things that I've told you about microbiome, it's because both Bovaer and seaweed kill the microbes in the rumen. Yeah, so they kill maybe a little bit selectively, the ones that are producing more methane. And so, yes, if you put a cow into an isolated room, which they do here at UNE in New England University, like a steel cage, where they measure the burp of the cow, maybe you get less methane out. Seaweed is really highly invasive, but it also has got 3 BRs, bromides in it. And they are an ozone depleting halogen. Yeah. So should we release that into the atmosphere through cows in massive amounts? Probably not, because we've just cleaned our ozone layer up. Yeah. So the argument is, though, why do we need it, and do we need it? So what is the thing with methane? And I just given a presentation at the Cattle Vet Association yearly conference. So if anybody wants it's about an hour long. Like my spiel about methane. And even my colleagues, are hellbound on getting more cows into feedlots to eat more grain. And now you know how that grain is grown. You also know what it does to the cows because it causes acidosis and disease. And they should not have grain. They should have fiber, not grain. They are in horrendous conditions because even if they look after them, like they are out of social contact, they are exposed to the sun, they should be grass eater, and not being full of grain. Then they get often fed growth hormone and antibiotics. And this is a recommendation from some universities, to reduce methane. And so my argument is only when you take it out of context. So can I put context around this? Yeah. So um, if anybody can go onto a TED talk that's interested, from Alan Savory and how to reverse desertification. So in a nutshell, if you now that we learned, photosynthesis takes the carbon, out of the atmosphere and pushes it into the ground. When the carbon out of the ground is in the ground and it feeds the microbes because they're just as hungry as in your gut. Yeah, and they need that sugar. This is the exchange, sugar against nutrients. It's a symbiosis. They give you the magnesium, calcium, iron, whatever you need, and the B vitamins and the amino acids, and they in exchange get the sugars from the plant. Yeah, then they build up organic matter. And then the organic matter holds the water, and the water is not in the atmosphere, so we can draw the water down there. The floods are 100%, we increase the water up there through modern farming so much. If we can change one thing, on the planet, if we change agriculture, we can heal a lot. Like 80%, like just top of my head there. However, so a cow comes along and eats the grass. And if a cow would not come and not eat the grass, and you can drive around next time you're in the countryside, drive around and look on the roadside, there's a lot of grass that's about a meter long and brown. Now, when it's brown, the chlorophyll is not working, it's dead. So, not working, not green, means it doesn't absorb carbon, it doesn't push sugar into the ground and feed the microbes and blah, blah. So, how do you get that dead grass to grow again? Yeah, because when it's growing again, it's actively absorbing carbon, it's pushing sugar in the ground, it increases the soil, and within 2 or 3 years on a regenerative farm, you increase the carbon or the organic matter in the soil that used to be about 8%, 9%, 10, 15, even 20%. Now, on average, below 1, that's your carbon. That's a big landmass from every inch of agricultural soil. It's puffed up into the air, right? So now you have got some ruminants come, yeah, and they eat the grass from that dead back down, and they wake it up and put it back into a juvenile stage. Same principle as if you want another flush of roses, you cut your roses. Yeah, you cut your roses to get the next rose. You take the geranium off. You cut your grass in your garden, and it's always green. If you don't cut it, it'll be brown and it'll die, and then biologically not active. So this is what herds of ruminants have done all over the planet. If it's in Africa, in the steppes, the zebras, the elephants, everything is just eating that biomass down. It disturbs it, it knocks it over, it tramples into the ground, it increases the carbon, it holds the water, and you have got healthy, fertile soil. Same as in America, middle of America. The big bison herds created the most fertile soil that there was on the planet. What do? We get the cattle off there, we glyphosate it, we have a dust bowl. We have, and then we grow that grain and then we send it to the feedlot to the cattle in California. But another thing that happens when these cows make the grass alive again, and it's fascinating to see in what short time, like a year or two, your dead soil that you could not get a spade in, and I just did it last week. I did it all the time. You can't even, with all your frost, you can't go in there. It's like concrete. And then you have got grass growing, and within 1 year, it's as soft as butter. Why? Because it's got carbon, it's got biomass, it's got life, it's got microorganisms. There should be more carbon down underground than above ground. So the beautiful thing about herds of cattle doing this and waking the grass up. So now the next thing happens. When we have, I know it's a lot, but it's really important. And it's important for people to know because we vilify cows and you would get vilified about, carnivore diet is bad for the planet. No, it's not.
Yeah.
So the cattle that are going through landscapes absorb the carbon and get the small water cycle growing again. The vegetation that comes, and I mean, may I just add, not every country should be under cows. Yeah, like there is alpine, there is marshes, like there's wetlands, like have them where there should be, but grasslands are magic. So when now this grassland has been recreated by cattle, in the morning you see fog. Yeah, while you go onto agricultural land that's been poisoned, there is no fog. There's no moisture in the air. But when cows are on grasslands, you get fog and mist rise. That fog and mist is water, H2O. As soon as the sunlight hits it, it is split into an OH minus and an H plus. And that little OH minus is called a hydroxy molecule. And you can find it also on the internet, Nobel Prize winner, about calling that hydroxy molecule the detergent of the atmosphere. And that methane that cow is burping out, which you can measure if you want to, it does not even get up into the atmosphere in these healthy grasslands because the OH minus, the hydroxy molecule, just puffs it into CO2 and water.
Oh, I
Straight
mean,
away.
that's just sort of golden point there because
Yeah,
the missing link and that just
yeah,
explains why shoving cattle into these massive cattle yards where there is no vegetation, where there is no fog, where there's no moisture in the air is
yeah,
so
yeah.
silly.
So if then a
Um,
scientist comes and says to me that they had, a cow in UNE, at the university in a silver cage, and measuring the methane, and it might burp less methane if it is on Bovaer, seaweed, and or grain with growth hormones and antibiotics added, which creates the next wave of disease in humans and in the cow, then it is completely out of context. And cattle,
These people,
yeah.
they are unbelievable. They cannot see the forest from the trees. Dr. Gundi, I had a question when you were talking about Bovaer, and you were saying that it kills the microbes in the rumen of the cow, which then reduces the methane output. Does that also reduce the energy or nutrients, or because I assume if there's less microbes, then the cow's eating less, or it's getting less energy, or it's getting less nutrition because it feeds on them, right? On the bacteria. Am I on the right track here at all?
Yeah, you are. And I'm not a Bovaer specialist, and it's only been out for a really short time, so it shifts, let's say it shifts the microbes um, in some way to more microbes that don't emit so much CH4. So the food technologists, people say, all right, well, if they don't burp out the carbon, because it's all about carbon, it's all about protein, then they're putting on more weight. And I say, yes, but, the stuff is toxic. Why do we do, what next problem do we create?
Mm.
What does it do if it's so toxic? You shouldn't breathe it, you shouldn't eat it, you shouldn't drink it. And then we make our cattle do it. It's just a technological answer, again, to a problem that actually doesn't really exist,
Yeah.
creating probably the next problem down the road.
It's so
Like
short-sighted.
it's also that nature had these ruminants developed over so many millions of years to perfection. And now we think we can make it better.
Mm.
Why? Because somebody makes, and also the methane is the above ground carbon cycle. And yes, it is stronger than carbon. But if the cattle are in grasslands, the net carbon sequestration by cows in grasslands and the regreening, and not just the regreening, the transpiration, which is another concept that I would just like to introduce here. When you have got a plowed field, and when I was just in Mori last week, and I see all these cotton and the wheat fields lie barren, that soil has got a re-radiated heat, and there is a physical formula, the blah blah forgotten, where it's the re-radiated heat is such, it's by the power of four. And you know that if you stand on a plowed field and it's sort of black and it is hot and you cannot, on a hot summer's day, you really can't tolerate that heat. While if you are in vegetation on grasslands with some trees, you have transpiration. And my friend Walter Jenny is talking about this, so he's the expert in this. I learned this from him. And you can check him out on YouTube. The transpiration that comes from grasslands created by ruminants, the evaporation of water, especially in the morning and during the day, and the shade that it creates, and then and it covers the soil, so the re-radiated heat doesn't even get re-radiated, and we can absorb carbon or water as much as we want. Carbon would just be filled up from the oceans again into the atmosphere as a equilibrium. So that would take a long time for us to have some sort of climate effect. But if we cool planet Earth by not heating it up in the first place and by transpiration, which is like latent heat, and I'm not a physicist, but it's like an evaporative air conditioner where we cool these landscapes, then we can have impact. So I really am a fan of cows and carnivore to save the planet,
Mm.
which now maybe people can understand,
Yeah.
and
Well, I think that's a sort of a positive way to way to kind of wrap things up, because there is so much corruption, so much misunderstanding, so much short-sightedness, so much search for profit, that has led to all these well-meaning people, like people you mentioned before, vegetarians, vegans, the woke mob, etc. They're all well-meaning, and they're all trying to do what is right for the environment, but they are lacking the foundational understanding of how nature works. And Dr. Gundi, you have that knowledge, and you've sort of explained it in more detail than I think anyone that I've ever really heard. I think the challenge is for you to communicate that to the masses and the public, because they will change their behavior, they will change their voting, they will change their expectations, they'll stop falling for the greenwashing. But the depth of information that you provided there, I mean, I'm listening intently. I'm a normal person. I'm trying to understand. It's a lot to take in. I was terrible at biology and chemistry, etc. at school. And I'm trying to understand it through you now. We need to translate your knowledge into something that your everyday person can understand. And sort of on that, I think one of the big ways that people can do it is leave your city, go and visit a farmer, see the difference between, you can go all over Australia, you will find regeneratively run farms next door to conventionally run farms, which means they use a heap of chemical.
Mm.
And you can see the difference in the life in the soil. You can see the difference in the animals that are being produced and the output, etc. And the resilience when it comes to droughts and floods, like you were talking about before, and fires. It's out there. We just need more people to be open to hearing this message, and we need a good way of delivering it. You know, that your everyman can understand.
Yeah, 100%, like, and yeah, it seems to be so out there to say, cattle will save the planet, like, and it is so counter narrative at the moment,
Yeah, honestly, it sounds provocative to your
Yeah.
person who thinks that, eating steak is going to kill the planet, and that eating
Yeah.
their quinoa that's been shipped all, halfway across the
Yeah.
world is good for the planet. Like, it's they just can't get their heads around it.
Yeah, but another point that you made is, like the shipping around the world, like, so it's in the discernment of the how, so grass fed, and it's really got to be grass fed and local, so if you can find a local farmer, like I get my meat all from around here, from friends of mine, and I know that those animals have been really treated well, because that's really, really important. And another important point is that there is many ways that we think we can save the planet, like, and vegetarians, vegans are number one, they are definitely on our side in saving the planet, and wanting to be healthy. And now I come and say, yeah, but go and look at it and look how many chemicals, blueberries, like 20 different pesticides on blueberries, on strawberries, broccoli, the tomatoes, and bread and wheat and soy are the worst. And and canola, the seed oils, that are making us so sick, like, and we can talk about sugar and inflammation and heart disease and cholesterol another time, like, what a lot of not truth. Yeah. Like, that is why, since we have started eating like that, suddenly 93% of Americans are metabolically unstable. Diabetes is taking over the world. Our children are autistic. We have cancer, was just on the ABC, a cancer epidemic. Why? Like, well, it might have something to do with what we eat, but also how we grow. This is my message now. How we grow it really matters, and what we grow. And the cleanest, because we got to eat something, like, we can't starve to death, all of us. So what I look at it like, and I've decided for me, with my knowledge, that eating grass-fed ruminants like cow and lamb that have had a really happy life on farms like mine, where there's trees and grass. It's not trees or grass, it's trees and grass. There's insects, they're the bottom of the food chain. There's healthy soil. The water that runs off these farms is clear. And that to me is, if I've got to eat something, that is my choice. That is what I will eat, because I do the least harm. And in a way, I've provided this animal with a good life until 1 second it's gone, and that still breaks my heart. But also, I'm part of planet Earth, and I got to eat something, and the eat and get eaten has started like 3 billion years ago in the soil, when the first bacteria ate each other and the first protozoa came and ate the bacteria. And that is the cycle of life, and that is nature, and we are part of that. But we have disregarded all of those natural principles.
Very well said.
Mm.
Dr. Gundi Rhoades, thank you so much for your time. I really appreciate you sharing your knowledge. That was incredible. Thank you so much.
My pleasure. I hope it